We are here to learn. So next speaker, Daniel, you can come forward. Okay, so thank you guys. We are switching to the next speaker, Daniel from AWS. He's going to give us a hint about attackers' TTPs as they reflect from the AWS search. The floor is yours. Can you test your mic for a second to see if it's working?
Can you hear me? Can you hear me well? Raise your hands if you can hear me. Okay, great. Hey everyone, welcome to Common Threat Actor Tactics observed by AWS Customer Incident Response Team. I know it's a long name, but I'm Daniel Begimher. I'm a senior security engineer in the AWS Customer Incident Response Team. And today I'm here to share with you what we see in the field, which experience we have in the field, and hopefully to help you to mitigate and secure your environments. So we're going to have 20 minutes. At the beginning, I'm going to intro my team, the AWS Customer Incident Response Team, what we do, how we can help you. After that, I'm going to dive deep into the current threat tactics that we see on the field. What do we see from live security events, and how you can mitigate them in your environment. And in the end, I'm going to give you next steps, best practices, recommendations, resources that you can take and implement in your environments. So who are we, the AWS Customer Incident Response Team? It's a global team, worldwide, across the globe, and we're helping customers with their security incidents. The team is specialized on cloud security and incident response, and we're helping customers when they need help, when they're reaching out to us, to investigate, identify the root cause analysis, recovery from live security events. In the end, we also provide recommendations, short-term and long-term recommendations that can help them to secure their environment. Now, the team and our work is focused on the customer side of the shared responsibility team. Everyone here is aware, know the AWS shared responsibility team? Raise your hand if you're familiar with this concept. All right, so I'm going to touch base on this. So when we talk about shared responsibility, we have the security in the cloud and the security of the cloud. So for the security of the cloud is how we manage the physical security, the infrastructure, the cooling system. All of that is managed by us, by AWS. You as a customer, you're responsible about how you configure, how you set up your environment. So if we think on an example, if we have like an EC2 machine, a virtual machine, we will give you the infrastructure, the APIs to create it and provision it in the AWS environment, in your VPC. We will make sure it's available. We'll make sure you have the relevant resources that you ask for. It's your responsibility to configure it. You decide which application to deploy there, how to maintain the vulnerability management program, who has access to this machine, who can manage this machine using SSH, etc. Now, during this session, and what my team is doing is all about the customer side of the shared responsibility model. So why I'm here today? As I mentioned before, me and my team, we see security events 24/7 across the globe. We see the challenges the customers are facing there. In AWS, security is top priority. So we want to share this information with you. We want to share this experience with you. We want to share what we see and how you can mitigate or avoid the next security event. OK, so I gave a short intro about the AWS Customer Incident Response Team. I hope none of you will have any security events, but if it happens, you can reach out to us. You can reach out using your account team or using the support, and we can help you. After we discussed about the AWS CERT, I want to dive deep into the current trends that we see on the field. What is really happening out there? A disclaimer, again, I'm going to focus about the customer side of the shared responsibility team. I'm not going to talk about AWS vulnerabilities or anything related to AWS. It's, again, customer environments and what we saw on the field. Now, take into consideration that this is also a short session. We have 20 minutes in total. And I won't be able to cover everything, but I'm going to give some examples and some examples of mitigations that hopefully you can implement in your environment. Let's start with resource hijacking. A threat actor that gets access somehow to an AWS account or to a resource. Now, the root cause for that can be different, right? Like it can be leaked credentials or application vulnerability or phishing attack, but we're in a situation when we have a threat actor in our environment. The next step that we'll usually do is we'll try to get benefit out of it, right? Try to add cryptocurrency mining. Try to find a way to mine there. We can identify that using those API calls. So run instances, for example, create and run new EC2 instances in the environment, create stack, creating a new CloudFormation template and provisioning it in the environment, or create cluster, create a Kubernetes or ECS cluster to start spinning up compute resources in order to run those cryptocurrency. Another common thing that we see is the usage of unused regions. I assume that most of you, if you have cloud workloads, if you have AWS workloads, you're using probably several regions for your workloads, maybe 1, 2, 3, maybe more than that if you're a global company. But eventually you have the regions that you know. And we see that, that unauthorized users trying to run those cryptocurrency or any other workloads in the unused regions because there are less monitoring them, less detection capabilities there. Users are not logging on to those regions, so it takes longer time to detect any vulnerabilities there. So what can you do? First of all, don't allow users to use unused regions, right? You can do that using different controls, such as service control policies. It's a policy on AWS that you can attach to AWS account or accounts. You want to adopt the principle of least privilege, and this has been discussed today here several times, right? And I'm going to repeat this as well during this presentation. We want to make sure that the identity, the principal, doesn't have permissions or allowed to run any actions if it don't need it for its day-to-day job, right? And we want to leverage MFA, multi-factor authentication. This comes in place like it's super critical in relation to phishing attacks. So make sure that we have MFA enabled across our different users. The next topic, subdomain takeover, DNS dangling. So we have a customer, and he has a DNS record, CNAME record, and it points into an existing resource. It can be an EC2 instance, an S3 bucket, etc. And the customer doesn't need this resource anymore. He's deleting this resource. But the CNAME record, the DNS record, it's still pointing to that S3 bucket, even though it's not exist anymore. Threat actor identifies that, and he creates a new S3 bucket with the same name. And what happens is that the traffic of the users will go to that new S3 bucket. Let's see how it looks. So we have our customer creating a new S3 bucket, giving it a unique name because the name on S3 is uniquely identified, unique DNS name. It's going to have the DNS name, and then we have our DNS record that points into that S3 bucket. Now, the customer don't need this resource anymore. The S3 bucket is done. We don't need this website anymore. We finished with this temporary campaign. He's deleting it. The record is still there. The threat actor identified that. He creates the exact same S3 bucket with the exact same name. And what will happen, that the traffic will be routed to our malicious S3 bucket. Now, this is risky because the threat actor can do whatever he wants in that S3 bucket, create a new static website, and our users will reach out to that malicious website. How we can mitigate that? So first of all, let's make sure that we're reviewing our DNS records. We're reviewing our CNAMEs. We're identifying any unused records in our zones. The second thing is more like a process that we need to implement. We have a resource. We want to delete this resource. Let's delete the CNAME before we're deleting this resource. The next topic is data destruction. I have data on my AWS account, on my S3, on my RDS, databases, and I have a threat actor that has access to it, and he starts to delete this sensitive data. We can identify this from different angles. This is some examples of API actions that might give us a hint that it's happening. So delete bucket, deleting the all S3 bucket, or delete object if I'm starting to delete object one by one. How we can mitigate that? So I have a couple of examples here. First of all, I want to make sure that I have the relevant policies in my environment. Some examples can be resource policy, S3 bucket policy. I can control there who can access my data, from where. I can use lifecycle policies. So if I have data that I need to store for a long time, I can create a policy that after a year, we lock it. And no one can access it unless there is like a special procedure in order to extract this data. I can use S3 object lock that makes sure that it's right once and no one can delete or modify the data on my bucket. Again, the principle of least privilege, we discussed it before. Here it's also relevant. Who has access to my data? Who needs access to my data? If they need access, why they need delete? Maybe they only need get, right? And backup and restore. We want to make sure we're running backup operations, but we also want to make sure we have the restore functioning and it meets our RTO, RPO of the organization. The next topic, IMDS version 1 credential access, instance metadata service. Anyone heard about this feature service before? Raise your hands if you heard about instance metadata service. Okay, so what is IMDS? What is instance metadata service? So it's a service that is accessible from EC2 instances. And you can interact with it in order to get some information about the instance. So some examples include getting the tagging, getting network information, understanding the instance ID. It's a very useful service that you can use in order to create different operations in your environment. Now, this service also, you can, by creating a request to it, you can also get the instance credentials, okay? So if you have a threat actor with access to the EC2, and he's using instance metadata service version 1, he can use this in order to get the temporary credentials from this EC2. And after he gets them, he can just use them in his environment and run different actions in the AWS environment. I want to visualize how it looks. So this is like an example of a curl, an API call into the instance metadata service. And you can see here that you're trying to reach out to this address, 169, et cetera. And you get back the session access key and secret key with temporary access. You have an expiration date. But like, if you get that and extract that from there, you can use it in other environments. Now, the access to the metadata to this example, it's very common around SSRF attacks. So I'm going to give example around SSRF attack and how our threat actor leverage that. So here we have our threat actor, and we have some vulnerable web application to SSRF. He's sending a request to this EC2 instance, and from there he's sending a request to the metadata service. He gets back the credentials. And he uses these credentials from his environments in order to create resources, extract data, etc. How we can mitigate that? First of all, we want to require version 2. We published an update for the metadata service, and version 2 can mitigate most of the attacks, of the risks around the example that I've just shared. There are some hardening that we did there. I'm not going to dive into details, but it can allow you to make sure that the request really originated from the EC2 instance, and the credentials won't be able to use for other environments. The principle of least privilege, I told you I'm going to repeat this a couple of times today, and it was discussed, I think, all or most of the sessions previously. So it's relevant as well, right? Because if the EC2 instance has only access to read or do specific actions, even if a threat actor would be able to extract it, you won't be able to do much because it will get access denied. And we also have options to use conditions in our policies. Okay, so here there are some examples. So we can include in our IAM policy some conditions. you can only come from this VPC, from this EC2 instance, and by that, you can also reduce and mitigate the risk of this kind of attack. All right, so I gave a couple of examples of tactics that we see on the field. Share with you about the customer incident response team, and as next steps, I want to share with you some resources, some best practices, things that I want you to take and implement in your environment. Okay? So the first thing, update your contact information. In your AWS account, you have your contact information. If something happened in your environment, if we identify something, we will reach out to you using the security contact. Make sure it's up to date. Make sure it's monitored. Make sure it's distribution list, and the team monitoring that, something which is super critical. The next thing, least privilege, right? We discuss about it the whole day. Very easy to talk about it. To implement it is a different story, right? So we have some tools that can help you to achieve that. We have the Access Advisor on IAM, which you can log into and see what your identities did recently, which resources they reached out recently, and when. We have the credentials report, and I think it's been discussed also in the previous panel. So with the credentials report, you can output an Excel spreadsheet of all of your IAM users, when they've been used recently, who has access key, when it was used, who has MFA and who doesn't have MFA. And IAM Access Analyzer. IAM Access Analyzer, it's a super powerful AWS service. And you can use it for different actions. The majority of them is without any additional costs. And you can use it in order to identify which resources are publicly available, who has access to your resources, which privileges your identities needs, right? It checks on CloudTrail, which is the audit log, and it can generate for you a policy based on the real actions that has been made by the identity. So highly recommend. The next thing is patch management. Make sure you have a patch management program, both for your operation systems, both for your applications, third-party dependencies. You can use SSM Session Manager, System Manager, or you can use any other tool that you used to use. Just make sure you're patching and have a vulnerability management program. The next thing is training simulations. If you have an incident response team, or you have the team that handles incidents in your organization, make sure they know how to handle cloud security events. Make sure they're trained, they have the relevant resources. Make sure you're running simulations with them and check how they prepare for the next security event. If you encounter any security event, learn from it, right? Understand what happened, what was the root cause, and try to include it earlier as possible in the process in order to mitigate and respond to events better. And I'm going to share with you some resources that you can really share with your team, okay? So I have here like a couple of guides and white papers. So we have our AWS incident response guide, which can help you to understand how to build an incident response program, what to look for. We have our public blog of the customer incident response team, where we publish and talk about security events. We have our foundational security best practices standard, which is how you need to configure your AWS environment to make sure you're aligned with security best practices. We have some tools which you can use. So Athena Bootstrap. Athena is a serverless analytics service on AWS. And we have an open source tool that can help you to bootstrap an environment for investigation from predefined queries that you can use for investigations. We have the assisted log enabler. We discussed previously also like about different log sources. So with the assisted log enabler, you can, with a couple of clicks, enable different log sources in your environment and make sure you prepare for the next security event. We have playbooks and runbooks that you can use. So we have examples on our public GitHub of template of AWS security events, and you can use them in order to define your own playbook and runbooks. And we have some workshops and training which we can watch and try. So we have the public security workshops, which are training workshops that you can run with your teams. They're publicly available. And you can learn there how to handle and how to react to security events. And we have our live Twitch, with which my team members are discussing different security events and trends based on what they saw in the field. So as you already guessed, probably all of the links are available here in the QR code. So that was the session. Thank you very much. I don't think we have time for questions, but feel free to reach out to me if you want to discuss.
Okay, guys, this is a wrap. Thank you, Daniel, for all the insights. Yeah, it was excellent. Yeah, it's not too often we see the behind the scenes for the cloud providers, so thank you for sharing all this information. Guys, this is a wrap. Thank you for coming. If you want to hear more about our activities, we look for the Facebook group, Cloud Security Alliance Israel. Join us there. We will announce our next research, our next events, and so on. If you don't find it, ping me on LinkedIn, and I'll send you the link. And enjoy Cyber Week. Have a great one. Bye-bye.